Hello, everybody. Looks like we made it to the end of the semester. Tonight's the last night. Um, we covered all the major learning objectives that were set out, but again, this course was sort of a trial run. Committee already curriculum committee already discussed it and decided to include this course. And when I wrote up the core for it, I wanted to give it a trial run before actually taking it back to the committee. We've been through our major course learning objectives that were on there, and I was edited some over the summer. Went over a lot of stuff, but we made it to the end of the semester here. And probably kind of a short night tonight. Unlike Tuesday, where I thought it was going to be a short night, and it stretched out a little bit, stretched out to 7:30. It'll be shorter than that. It's a bunch of small scattered things to look at this evening, things that might be useful. I guess first off, I'll start with one that's very common. You may have encountered it before. We can do it with any repository. It is particularly popular on GitHub, and kind of the reason websites like GitHub were set up. They're useful for storing our stuff. GitHub has all those project management functionality tools built in. That wasn't a very good sentence, but all those project management tools are included there. But the original reason sites like that were set up was kind of for working on open source code. If somebody writes some code and they just want to share it with the world so other people can use it, they can download the source code, extend it. Which that we can just download the source code and make our own additions to it. But sometimes other people will see the idea or the idea of open source is more than just download the files and work with it. Sometimes other people will see something that's going on in an open source program and they'll want to add actual functionality back to the actual one, not just their own copy of it. And so a good way to do that is with version control, like we've been studying in this class in Git, but we don't want to fully separate the repository. We don't want to separate it fully into another repository. We still want to have a connection back so that if things go really, really well in our idea, that original open source project that we extended, we can do a pull request and bring our extension back to the original one, not just a separate copy of it. And that's what forking is for. I'll go on here. There's one built in octocat.spark tonight. Support. So github.com/octocat spoon knife. Oh, capital S. Spoon-knife. This repository is from somebody that works at GitHub, one of the people that actually works there managing the site. They put up a repository to practice forking with, which is really easy. Oh, once I get the Zoom buttons out of the way here. You just come in here and you'll notice over on the right, you can follow things. Sometimes that kind of seems like social media stuff following there. It should be a little bit different here. The following here should be when you're like watching for a particular bug to be fixed or something. Right? It's like, oh, I really love that software, but there's a big bug, so I can't use it until that bug's fixed. So you watch your repository and then you get notified when they update the bug report and close that issue. So you know when things are fixed and stuff. There's other reasons to use watch, but right beside that is this button for fork. If we click that, we can create a new fork off of this. There's by default, it has the same name, brings in the same description. Copy the main branch only. That's like the second or third thing on this list of scattered notes I have, but I'll just go ahead and copy the main branch only. And when we create a fork, Now back in my account. Okay, yeah. Notice it jumped right back to my account and said, there's a copy of that repository here. Which we could have got the same effect by just downloading the zip file, unzipping that and uploading it to a repository on my account. That would all be the same. But there are still connections back to the original one. Notice that we still see that number of how many times this repository has been forked. This particular one has a really high number because this was set up in the GitHub documentation. This is the official tutorial example. This is why I went ahead and pulled this one up. It's connected and we can do other things with it. Combine multiple open source projects and can I see it from here? I don't think it shows up on this. Yeah, so notice it does show up. So notice where the pull request is going. It's not a pull request to merge branches here on my repository. The pull request goes back to that original. So whoever Octocat is, if we make changes, they can decide to. It'll make the pull request asking them if it's okay to actually merge the changes in. So it separates it, but it's still connected, spins off. The idea of it is for extending open source code. Lots of reasons to do that. The group projects in here might be a good example of that. So one group did a rock, paper, scissors game, and the other group did a battleship game. I don't know if y'all have looked at and communicated about the other group's projects, but maybe you think, oh, well, those games could go together really, really well. So you could fork off of the other group's project as well as yours and tie those together into a single repository and I guess have like a battleship rock, paper, scissors, where you set up rocks and papers and scissors over a board and then the opponent tries to not just pick which particular squares on the grid like battleship, but which of the things to play in that grid, if that makes sense. But those things like that, those would be games that could possibly be combined. And instead of just picking that grid for battleship, have to pick rock, paper, scissors in each particular grid. Can be a very useful thing, primarily for extending open source code, which is really, really useful. Some open source projects have gotten very, very large, grown massive over the years. And that's kind of what GitHub were originally created for, was to share the open source code. Because if it was all proprietary software, that wouldn't be a very good idea, because then you risk losing money if lots of people have your code. But it has definitely extended far beyond the open source community. So you might want to try forking things some and see what you can do with it. You do have to fork off of somebody else's repository. We're going to take through our own with it. You might want to give it 5 minutes. Kind of like, well, I can show you what it looks like. It'll make sense. Zoom back very well. It makes sense when you see the error message. Hi, Sam.
Hello.
We were just talking about forking. It splits off to a copy of this button right over here.
Oh, yeah.
So the original purpose of GitHub, fork off an open source thing, and then the pull requests go back to the original repository. So if we want to just use open source code and make add our own little function or our own icon on it or something, like what VS Code is, like what Microsoft did with the Electron framework. They just downloaded the zip file and then put their own logo on it, as opposed to staying connected to the original open source project and then just sending the changes back. Which they didn't make any changes to the logo in that particular example, but it sounds bad, but they really were out to prove the point that it is legal to do that. That question came up, and that was one of the things that they're like, no, it's perfectly legal to just put your logo on something. They didn't sell it, but they were proving to some people that you can. You just download open source code, put your own logo on it, and sell it, and that is not illegal. Under at least 2 of the 3 main license agreements, that's not illegal. Yeah, but if you're on your own repository, like, yeah, can't afford this repository because you own this repository, so it doesn't make any sense to fork the repository. You can just do a regular. You can just create a new branch on the repository. So if anybody wants to practice that, you might want to get with one of your classmates or something. But there's different reasons why that might be useful. Not just the original open source link. Well, like that was kind of the main reason GitHub was created to begin with, and people have found lots and lots and lots of other reasons to use GitHub. So it's like that. We have a tool, lots of the different things we can do with it. What's next? Have some odds and ends that'll be useful here. Clone a single branch of a repository. Put that on here. I don't know why I was carrying those notes back over there. I set them on that desk. I have to walk over and grab them again in 5 minutes. Do I have a repository you can use? I don't know.
I have a quick question with the forking. If the original is deleted, the your forked copy still exists, correct?
Yes. Yes. It wouldn't merge back to it. And on GitHub, I know GitHub does this. If the original is deleted and there's a bunch of forks going off of it, people that try to navigate to that URL will get a special 404 message that says where the forks are. So the original one's gone, but here are some of the forks off of it so that you can still get to the project. You can still get to that project. So yes, definitely. For the next thing, I need something with a bunch of branches on it. So I'm going to go into the homework assignment from module 3 or 4. Does anybody remember when that was? I can download it all from files. I have access to the files directly, so I'll grab it from here. Homework. And nope, actually, that's not very helpful. Apparently named all the folders, module 3, module 4. The one with all the branches where we had to merge branches, was that this one? Oh, yeah, working with branches. This one has lots of branches. That'll work for the thing I wanted to show. And yeah, when I was putting this one together, this one now. Yeah. Delete confidential information. Didn't realize that was still on there. Okay. I usually go through and check the folders right before classes so I don't accidentally open files that shouldn't be opened in public and things like that. So here's that one we did. I guess it's a couple. Yeah, there's the .git folder. So PowerShell, Git, log, one line. I think y'all remember this time. We have lots of branches. The head is pointing at main. So if I wanted to make a clone of this, which this way. Something to notice, it shows up when we clone from GitHub. Notice we have the file path. And then over here, there's the .git folder. Well, the screen's fine. Okay, there it is on my screen. Shows up on TV now. The .git folder, and when we clone a repository, we do the URL .git. What we actually want is that folder that has all of our Git information. So that's why that extension is on there. But in general, if you leave that extension off, it will try to apply it. But that's the folder we actually want. That's the folder we actually want to get. And when we grab that folder, all those snapshots and everything else just get dragged along with it. So it's not necessarily a file extension in the traditional sense. I always refer to it that way, and we'll probably continue to refer to it that way. But while I'm copying the URL here, that just popped in my mind, I should say something about that. Because we actually want that hidden folder, so we do dot instead of slash git. So it's still just the file path to that, but since we use a dot, it looks like an extension. That it's less confusing if we use the extension. So let me go over to documents and delete folder. There we go. So I'm gonna clone that repository, git clone, paste all that, then dot instead of slash to indicate hidden folder, git. But generally, it probably makes a lot more sense just to think of that as an extension. So we've seen that before, nothing special there, right? But if I do git status, oh, whoops. Let me navigate into that. Did I clone? Maybe I don't need the, let me try it without that. Oh, okay. Well, it pulled the folder off without that, so. I guess that point, as it just said, was unnecessary to describe, but that is what happens when we download it. It's just grabbing that folder. In here. So no surprises here, right? Try to get status. If I try to type get status but get it wrong, we see this. That's something else coming up on the list. Yeah, very, very soon. Typos are annoying. We make those. It'd be nice if the computer could just fix those for us. If we type get status, it says we're on the main branch. But maybe we didn't want the main branch. Right? That's maybe we wanted another branch. That should be the downloads folder. Nope. We don't have too many. Then in the downloads, then in module 03 _ given. Oops. If I can spell it correctly. Again, with the typos, it'd be nice if the computer would just fix those for us. Knowing that we're going to make them.
I'm still trying to not type online instead of one line or one line. Yeah.
Oh, yeah, that one lasts for years. It takes it, yeah, that's one that just like never goes away. Git log, one line. But again, it'd be nice since that happens so often. It'd be nice if the computer could just fix that for us. So there is, there's our original repository. It's pointing at the head. So when we cloned it, we got that main branch. Oh. I think I must have disappeared. It was already here. I'll give it a second so his microphone gets back on. Make sure his mic came back on. Okay. Yeah, so over here in the original repository, the head is pointed to main, so when we cloned it, we got the main. And we saw before, we can just check out any of the other branches. I can navigate back over to the other spot. I probably should have saved it. Up level, up level, up level, and into documents. Delete folder. Then in here. Git branch -A. We can check out some of the others, like maybe we actually wanted the more another branch. So we could just do git check out more another. That red looks really strange here, and that gets us the other branch. Git branch -A. We saw all that before. On the other branch, the original head is pointing somewhere else. Make sure that git remote show origin. And we have all that stuff, ones that are tracked, the ones we pulled down. Everything's up to date. We saw all that information, but if we knew we wanted this branch, there's extra steps involved in getting that when we clone it. So let me go back up a level. And oh yes, that happens. Wi-Fi went out, and I'm going to delete that one because when I clone it, it's going to try to bring it in with the same name. If you haven't noticed yet that it's write protected, or it's write protected to an extent. It's write protected against delete. If we're in the terminal, we have to do extra force parameters and stuff. So I usually go over here to delete it. But if I want to, that's still on the clipboard. Yes, okay. So we could clone, add in -B and say we want just a particular branch. I think it was another more. And then single dash branch. So if we did git clone -B another more, even though the head is pointing at the main branch, that's going to bring in the other one. I don't think we saw that before. But we can also say single branch and just bring in that one branch because we don't need the rest of it. And then the one we want to, and then the URL we want to clone. Was that another name of it? I'm going to open another PowerShell so that I don't have to navigate back and forth between. Probably should have did this to begin with. I think it's 2 folders deep. MO3 given. Yeah. Git branch -A. More another, is that not what? Nope, I typed another more. Let me try that again. So the branch we want is more another. There we go. So now we clone that over. So if we let's see, it brought the name of the repository like we were expecting, MO3_human. Have the files in it. That's not what I meant to hit. Git log one line. And you can see we're pointing at that. We only got that other branch. Like only that other branch. We don't even have a remote connection to the other ones. That can be incredibly useful because sometimes repositories get very, very, very large. Right? In modern software example, it was in the news last year. News wanted to put a bad spin on it, saying Facebook laid off 11,000 programmers. The 42,000 programmers Facebook hired successfully completed their project, and the next project only required 32,000 programmers. Those people got a really nice severance package. It wasn't like when a local factory lays somebody off, or I think several of you all in this class know what it's like when Amazon lays people off. That's not so good. Facebook is really, really, really nice to the people they lay off, and it only technically fits that definition, but they need 11,000 less programmers. So 42,000 programmers worked on one project. Have I brought that up in class before? I bring up the question like, what does Facebook do? What did Facebook do with 42,000 programmers? They didn't change their style sheet. I like to bring up that
Work on
question.
Meta.
That was they standardized XR. So augmented reality and virtual reality. And which actually, I guess you could say they created XR because those were two separate things. They brought them together and made standard libraries so that everybody has to follow, so that there's one way to do it. They basically set up conventions on virtual reality. Makes it so much easier to program because now all the game engines can use the same plugins. And you don't have to wait years for somebody to develop it for a different game engine. You can just grab the standardized library for both virtual and augmented reality. But 42,000 programmers worked on that. Imagine how big that repository was. They were probably spread out amongst lots and lots of smaller repositories that were still massive. When you went to clone it, you probably have to wait five minutes for stuff to download, 10 minutes. And that's if you're like at Facebook's headquarters with what you know is a great internet connection. Just like massive files of code. So being able to get just one single branch, just clone a small piece of it instead of the entire thing can be really, really useful. In our class examples, it's kind of trivial, but that's a useful one. You can also put the -B in a branch, and then you get the normal full connection to the repository, but it changes where the head's pointing at. It's the single branch parameter that makes a big difference there. I'll read it here. I don't know why I grabbed my notes and keep trying to put them back on that desk for some reason. I need them over here where I'm actually working at. Or maybe we want to just break things off. What is it, that part I get log one line? So we have this commit here, this one in the middle. There was some stuff before it, some stuff after it. Actually, I'll use the last one. So this is the part we want. Maybe this is the only part we wanted from that. The next one kind of leads from that. There's other reasons to use this, but I guess it makes sense. We grabbed just that little bitty piece of the full repository instead of the whole thing and we cloned it. But really, we just wanted this one commit. And that's where orphan comes in. So when we go to check things out, so if we go to check out that commit, check out, and then add in the parameter -- orphan, and then our branch name. So maybe this last one, we're going to check out that. Notice we switched to a new branch. Let's finish. Notice the history is gone. So we pulled that one commit out by itself and created a new branch from it without the previous history. For here, if I choose any of these branches, git check out, where are we at? Git log one line graph. If I chose maybe this one, git check out this commit, git log one line, we still have all the history that led up to that commit. It's still part of the larger repository. There's this thing in this message, git switch dash. When I was putting, well, I started doing, I thought, I can't remember if I said, I probably said something, but I realized that some Git software, the GUI for that would be a good one for virtual reality. I've been looking for virtual reality, non-game virtual reality applications to do that. It's actually looking up, I've got the branches or boxes. So you like grab the box and put it on the desk, and that's how you check out the branch. Or bottom shelf of the desk, and then all the commits show up on top of the desk. I've been having fun with that. I get completely distracted. Oh yeah, probably did something different without even thinking about it, because I never used this one that's in the message. What I did is just checked out the branch that I was on previously. So we were on the main branch. So if we just go git check out main, it takes us out of that detached head state. When I wrote the code for that, I did that without even thinking about it. It's like, oh wait, we just kept doing what the error message says. You can do check out main or check out the commit that you were on, and that takes you right back to where you were without, if you're in the detached head state. So orphan kind of breaks it off, and then we have just that one commit with we no longer have any history to it or anything. Sort of, well, you can see right up here. When I tried to show the log, it thinks we haven't done any commits yet on this spot, on this thing. So sometimes that can become necessary. And I guess orphan fit really, really well with that check out a single branch. Then if we have a huge repository, well, like the original thing Git SCM was created for, if you're going to check out part of the Linux kernel, those are some very, very, very large repositories. Everybody seen pictures of those? Like they don't even fit on the screen, and they're not even readable if you try to fit them on the screen. Linux kernel, images, Linux kernel branches. Yeah. Linux distros, I bet that'll find it. Okay, yeah, like this. That picture, we just see sections of it. They come in, the pictures of it come in sections, and we have to put it back together. And that does eventually go back to a single branch. Not the original Linux kernel, well, it's probably on there, but Linux was around for 10 years before they built their own source code management because it got so big. So it was still pretty big, but if you tried to download all of that, you'd be waiting for a long time for that to download. So you probably want to clone just the one particular branch you need, and then break off that one commit, and then start working on your own custom distro of Linux. One of the primary reasons that software developers tend towards Linux, because we can do that. With Apple or with Mac OS and Windows, we're kind of stuck with that operating system. We can do some customization, but we can't remake it into our own operating system. Whereas Linux, we can. Orphan's really useful. View file in another branch. I think I can get back to it. So if I wanted to delete that file, I remove -R. Yeah. Remove PowerShell. Remove item mo3_given -recurse, and permission denied all the way through, because technically we still call it write protected. We're not stopped from any writing on it. We're just stopped from deleting. So it's just the one type of write, but we don't have a separate word for that. So I'm just going to delete this and clone it again. Something's still on the git clone. Oh, not on there anymore. Paste. There we go. All right, so git clone. Um, so, we're going to come up to like say here. That's that same branch again, isn't it? Get, check out more another. So we're looking at this branch, seeing all the files. I did not mean to clear that. I needed to point back up with the graph. So that was just out of habit. Let me go back to the main. Get log one line, graph, get log, get branch dash A. There we go. Now get check out more another and not clear the screen this time. So we have our files here. Okay, those all look good. We can see what's in them. Oh, I'm showing that you use the PowerShell commands. Cat does work to concatenate, but get contents is the modern way of doing that, the non-acronym with the nice naming conventions and everything. So people put a lot of thought into the function names in PowerShell. They'll have nice getters and setters and what they are. The contents or content? Maybe content. Get content, another file.txt. And we can see what's in there. But maybe we want to compare it to something that's going on over here on the another branch. So we can check that. I'm going to show all the file names on there. Get check out another underscore another. I'll go over here because I know at least one the name will have the file names here. Now I'll list things out. Okay, so we have file more here and more random stuff here. So we are on another branch which does not have the more random stuff.txt, but maybe we want to see that. This is the reason that posh git stuff never showed up, because so far this semester we've been changing back and forth between branches, have to keep track of which one we're on. We can see the other branches, but it never really fit in anywhere. So git show, we can just say show which branch was this on? This was on more another colon more random stuff.txt, and we can see what is in that other file. Apparently the words in that file are exactly the same as the name of it. I wasn't feeling very creative when I made that. That was like late in the evening and I'd been sitting there putting things together for hours and hours and hours. Or it wasn't late in the evening. Does that have times on here? It is not. Whenever I put it together, I've been sitting there for hours doing stuff. I wasn't feeling very creative. But we don't even have to switch branches. That's probably the main reason the hot get stuff didn't show up until we mentioned a discussion board of not being able to know which branch we're on. And I hadn't thought of that because we can just look at any one of the other branches. There's no spaces, branch name, colon, file name, or dot, accent all of them. Little tricks like that. You don't have to deal with spaces in terminals, just drop in quote marks if there are spaces in your file names, things. The normal terminal things, and it just runs the cat command. Which, yeah, I made it a point to look at get content. And I just said this does run cat command. And now is why we get this when we download. Yeah. Here in a moment, I think we're gonna look at this evening. Will require this as well. We need something we know is gonna run. And some people on our team might be looking at some people in our team might be working at the repository on PowerShell. Some people might be using command prompt. Some people might be using Zeesh. Some people might be using Fish, ZSH. That I go ahead and pronounce it. It's only 3 letters, so some people just say it. But I kind of like the name when you pronounce that. The Zeesh sounds like a sigh or something. The one Mac recommends. Mac OS recommends. If you still have Bash on a Mac, you get every time you open the terminal, you get a message that says you need to switch to Zeesh. It's a cousin of Bash. You have to get fairly advanced before you find any differences between the two of them. Some people might be working directly in GitBash. So we need something. We need to run. If we need to run a script, we need to make sure it's going to work in everybody's terminal. So since this was created by Linux developers, they put it in a Bash shell with VI. So we can always do stuff that would work in Bash and VI because those install with Git SCM. So here, when I got the contents, I use the PowerShell method, but the one built into Git actually does have a Bash script that runs the cat command. So it will work no matter what terminal we're in. Two more things on this little list, and then something about that Bash is VI, and then the last thing to look at. Actually, I meant to start with that tonight. Well, yeah, let's look at that. Since I just mentioned VI is in there, it's probably a good segue. Jump over to the document. Actually, I meant to start with this one tonight. And then was excited about some of this other stuff. They're useful. They don't really fit in anything else. We've seen them, but yeah, just some parameters that didn't make our time constraint cut earlier in the semester when we looked at checkout, and so we usually use the basic functionality, but there's a lot more parameters in there that can be really useful. Lots of things in Git, and Git is a big deal in the modern world. Right? For software developers, one of the positions is going to be called GitOps. So it's DevOps, GitOps, CyberOps, NetOps, the actual operations stuff. There's going to be a Git operations person on any decent sized team that just does the Git stuff. And that's management level, so it pays better than typing your code too, by the way, if you hadn't thought about that part, right? The GitOps person is management level, and like in every industry everywhere, the manager gets paid more than a regular employee, which would be a software developer, and software developers make good money. So the managers of software developers, such as the GitOps person, make a little bit bigger of a paycheck. Commit certification. I chose to recommend the Linux Foundation one. If you've never taken a Linux Foundation certification, I'll do those. I think I'm better than those certifications because it's not multiple choice questions. They just record you doing a bunch of stuff in the back. There's no wait either. It's proctored, but you don't have to wait on a proctor. You like as soon as you put in your payment information, you can take the test right then. That's what I did, and the whole thing was done in an hour. I think there's like an hour and a half to take the test, but like paying and taking the test and all that was done in an hour, and then somebody comes back and watches the video of it. So the certification, this one does use VI. So before you go to do the certification, they have a GitOps certification if you want to try that. It's a $395 certification. This one's $79, or it was $79. Yep, I saw something on there.
I was gonna say, I looked at the price the other day. It was 175 and I couldn't find it, but 79. Not horrible.
They have a higher level get off. There are some things in the get off one that are specifically there to trick you and look for people that have been doing this for decades. So it's quite a bit harder. So it's not bad at all. If you feel like getting that certification, and remember all the stuff from class, it's gonna look like I took that certification 3 times when I was getting the course ready. Not actually including the tuition and stuff, but that way you have a certification that says you're shows expert level in Git, but it does use VI. So before you go take that, make sure you review all your VI stuff. Because that's the terminal they use. It's directly from Linux Foundation. Yeah, so that's there. And since VI was mentioned, I think might be a good segue. If you're gonna take that certification, make sure you quickly review VI. If you're in the command things at the bottom, I to insert mode, then escape to get back out of that. Colon space number turns on your number lines. Then you can jump between numbers, and you don't know how to Google you don't know how to Google the instructions there. Right? Just find the manual. It's just a bunch of hotkeys. You might want to review Q and W. Copy is Y, because back in the 1970s, yank and put seemed like they were going to be the terminology that took off instead of copy and paste. But the point was just make sure you review that certification does use VI. It's Linux Foundation, so it's not multiple choice questions on Git. You actually sit down and they do it through a Zoom call. They'll log you onto a Zoom call by yourself, and they just record the Zoom. And then they'll proctor it later. So if they hear people talk something from you, giving you answers, right, that's a problem. But they record what you're doing. So not like most certifications where you just answer questions about stuff. Okay, I'll go back here. What we're doing. This is the thing I mentioned earlier. So check the status, but make a typo. Humans are prone to typos. That would happen on the phone, would it? Well, yeah. If we were doing Git stuff on our phone, like we had Terminix pulled up, autocorrect would restrict the number of words. So computers can fix those typos for us. If we were just typing in a text message, stats would go through because that is a common word. But it knows what it tells us what the closest thing we were trying to what we typed in was. So it'd be nice if we could just go ahead and do that, and it can, but we have to set it as a global configuration. So our system config file is read-only, so we have to do that from the terminal. For a global config file, we could just go in that .git folder and just change it in the text file. Git config -- global. And if we change help.autocorrect to a 1, it should fix that problem for us now. So autocorrect is built into Git as well. Hopefully you can, I assume you can see why I waited till the very last day. One of the last things, the very last day of class to mention that autocorrect is in here, so we don't necessarily have to remember all these commands. Or we don't even have to type them correctly. But it is a global configuration, so set your global configuration to help.autocorrect, and it's 0 and 1 as in true or false. So just set it to true, and then let's try that one. Git log online. This one was mentioned a while ago. Yeah, that one like never seems to go away because one line is a very odd thing to type, but online is something that we type almost daily. Let's see if autocorrect will get that. Oh, no, Greg won't get the parameters. We'd have to write our own little script to pull the parameters. Put our own little script in there. Have pruning on there. That's for optimization. Let me write this and then our own little script to fix parameters would work. I was going to do something a little bit easier. But that'll make a nice segue to thing. 2 items on the list. So I don't skip over this other one. Yeah, our own little script in there whenever we look at the log would be really useful. But one last thing I haven't seen yet is optimization. So let me actually pull up the log. Online dash graph. So there's all these other branches that we're connected to. Man, that's part where I can check out the main. Yeah, that's right. You did delete that and go back to the main. There's all these other branches. A whole bunch of them have been merged into the main branch, but they still exist. If we're already run them back in, we don't really need those separate, so we can clean things up. Well, obviously, we can always clean things up. Right? Go through there and just delete the ones we don't need. Git branch -d and delete the branches we don't need anymore. But what we can see from our graph here, Git knows which ones have already been merged back to the main branch. So it can delete those for us as well. We don't need them as a separate branch anymore. And that's called pruning. Branches on the tree, and we can prune the branches. So Git and then GC for garbage collection. We don't use that as much as we once did. It's built into all of our major languages. That's why there are major languages, because it's really kind of a headache to manually do all that stuff. Most people even import C++ namespaces that have some garbage collection there, so that we don't have to manually take control of RAM. There was a time when programmers had to do that. It wasn't even that long ago. That if we created a variable, right, x equals 3, print 2 times x, we get back a 6, but then that 3 is still hanging out in RAM, wasting space, and even though we're never going to use it again. So it would be on the programmer to then manually go into that RAM spot and say, manually go in there and say, okay, we're done with this variable. Delete the reference name where that's stored in RAM, delete the value that was stored in RAM, and state that this spot in RAM is now free for other software on the computer to use. It was a headache to do that. That's why Java and Python are so popular, because those two have about the best garbage collection out there. They have excellent garbage collection. We never even think about it. We can still call the garbage collection. I do in Python class. Usually by the time we look at disassembler and look and show that it's still there. But GC for garbage collection. So nobody got rid of garbage collection as the language is improved, and we don't have to do that anymore. So it still exists. And --prune -now, which is one of the many ways we can prune. You all check the documentation on that. I'm pruning. And --aggressive will do the most thorough type of pruning and completely empty that stuff, free up our resources. Never do this. Maybe it's prune equals now. Sorry, prune, when do we want to run garbage collection? So I'm going to do it now, but we could set it for in a working situation. We probably would set it for sometime after 5 p.m. after everybody leaves for the day. not in the middle of the day when everybody's working on that same repository. Prune equals now, enumerated, so it's on 24 things. Did a bunch of stuff. We see a little difference here. Get log. Now, we don't see any difference from what we did. It cleaned things up though. It did go through, garden collection did go through and found 24 things that could be deleted and 22 things that could be compressed. So if we were to look at file size and stuff, it's taking up less space now. I don't know what we compressed, but compressing 22 things surely saves some space, and deleting stuff would have saved some space too. So just cleaning things up after we're done with it. We don't do it much anymore, but we do have to manually call that a git. It doesn't automatically clean up itself after itself the way our Python code does. And then we saw this, so we turned autocorrect on. I figured out a typo in the command. Git how git remake show origin. And in the command, it will do the autocorrect, but that common typo in the parameter. Where git log online, because that's just so much easier to type. Autocorrect won't catch our parameter. So we just have to watch out for that one, or write our own script. And I'll just keep using this repository. This is the last thing I want to show, or at least point towards. So to write our own script in that .git folder, you'll see this folder called hooks. And it comes with a whole bunch of samples. But these are things that sample things. We have to change these names. That's why they don't automatically run. But see how all those files have some name .sample? Those names get called. So if I was to make a file here called, in the hooks folder, I'll create a file pre-commit. I'll make a file called pre-commit without the .sample at the end. Or they gave a really good sample, so you could just open that up and rename it sample at the end if it does something useful. And here we need to write a script that will run right before we make our commit. You'll see where in a second. Have y'all think about scripting? It does have to be bash scripting. So when we install Git, we get git bash. And that way, you know what terminal people are using, what terminal and what operating system. The reason this is here is so that we know there is a terminal. We know we can run a bash script and it's going to, it'll be able to. So for consistency. So we need our shebang. bin/bash. So the actual executable for the bash script is in a folder called binaries. Oops. Linux directory. So root/bin for binaries is where our bash executable is, where most of them are. We call that a shebang. So a comment like quiet sign and then exclamation mark for loud. So shebang, and this can point to anything. I know in particular it's going to work like I did in Python, and then I write a Python script here. And then when I open, actually I'll show you that in a moment. That'll be useful. Y'all have seen Python, but we need this one to be a bash script. It uses 1970 syntax, but sometimes that can be a little confusing. I'm going to pull up a quick example. let's just echo something. So let's just echo, yay, we're making progress in our pre-commit. So now I'm going to save that, no file extension or anything. Okay, so we're in here. I saw add another file here. And that does get saved in the .git folder and the hooks folder, so save it right there. Extending .txt. Putting more stuff in this repository. Save that, close that. And now we can add that file and make a commit. And have it quickly. But now, right before it opened up the text editor, it ran that script, which was just printing those words out to the screen. So you can give little messages and stuff, pre-commit, post-commit. Those files that come in the hooks folder, those are the names we have. So you can go in there and work with things automatically and see when the keyboard and both there because we always hold part. So the pre-commit, and from that you can probably figure out pretty quickly what post-commit does. What do we have? Apply patch, commit message. So pre-commit is before the editor opens. Commit message is like when we close the editor. Right, when we close the editor, then we see a whole bunch, then we see that stuff that says it made the commit. So there is a split second in between those two. That's where the commit message shows up. Monitor watch, post for updates, supply patches. That's what we just did. Pre-merge, preparing the commit message. Pre-push, so before we push. This one happens after we connect to the remote repository. Hello. It's kind of describes all this show where it happens. GitHub.com/review /Francis-Chris 5/review. This one's on because that was one we did that I've been using to test as I do that VR and VR interface for all this stuff. So we have that. So we go in here, see the did I just call it review? Oh yeah, so we say git push origin main. We're ready to push it back to the main branch. And we hit enter, everything's up to date. So before those words come up, there was a pause though, right? Several steps happened. First off, it connected to the remote repository, and then it exchanged information. And in this case, it found out everything was up to date. So that's the message we got. Another one, it might be it exchanged information, made sure everything's still lined up. If it didn't, y'all have probably seen that message, right? Unable to push. Or if it did, then we see all the information about the successful push. So that gap after we connect and when we exchange information. So before this one comes up, like after we hit enter and before we get to work, the first message back from the server, the confirmation back from the server, that's where pre-push happens. Pre-rebase is when we open our rebase file and say what we want to change. Remember that, but we get rebase. Information is up to date. Get off. If this works. Get rebase. I don't think it's gonna work here. No, the branch is up to date. I guess I can go back to the other one. Or another. Okay, rebases, I want to do something. Do y'all remember that how it opened up a file, showed us everything that happened, and we would change a word, and then we'd get and then after that we'd make changes. That's where that file runs. So these that's where the hooks are. So if you want a particular script, you just put them in there. And these examples here, they're not trivial examples. They did put in things that will be really, really useful. Remote URL. You might have to look for a moment. There's what the while loops look like, the if else. Yeah, all of that stuff. I want to show you something about shebangs though, real quick. Oh, they ran it with SH. This will just look for whatever shell it can run in. So they didn't know what shell would be installed, so they just said running whatever. A bash shell will work because we always have bash there. Let me go over to Kali Linux. I'm going to Kali Linux on Ubuntu. I have to on the other Linux. I'd have to do Python 3, but echo print Perl.
Yeah.
Into read.py. There we go. So to run that, we do Python read.py. Oh, was it not there? Is it Python 3? Oh, okay. Guess I do have to use Python 3. So Python 3, I went to Kali Linux because I thought I had regular Python on here, but I guess I changed my environment available. We run Python 3 and then that file that was just created a moment ago. Yeah, I'll just run that again so it's on the screen. Python 3 greet.py. So we can see that works. But there's this big extra step involved there, right? We have to say how to open that and all of that. I was doing it in VI. Oh, whoops. We go in insert mode, and I apparently echoed the wrong thing. So that shebang, it works for anything. So we put our shebang and /bin/Python 3, because I know where that's at. So, whoops, in VI. So escape and then colon WQ for write and then quit. Now, if I list it out, we currently only have read and write permissions. So change that 755. So now we can see, oops, ls-l, we see we have executable permission on that now. And with that shebang in there, then you can just say greet.py.
I think you put it as Python, not Python 3.
Did I? Let me check. I did. That was what I did wrong there that time, but yes. So make sure you run it with the same, with whatever your Python interpreter is. So that's just saying, open this with the Python interpreter. We do that with a bash shell. I know everybody here seen Python before, so that one will probably be more useful. That's why you probably heard about people using Python for their shell scripts. It's a modern language syntax. We have all the stuff and we can just run it just like we do the traditional bash scripts. We can do that with any interpreted language. Doesn't work with like Java. But if you have an interpreted language, the ones that they take one line of code, turn that into something the machine can work with, and then run that, then come back and get the second line. And they kind of run right from the text file because we never actually compile it. We never make the file code. It just compiles line by line as it runs. What I forgot that last time, I forgot to put dash.slash. So we can see we have executable permissions. So look at the current directory. We have to tell it where it's at if we actually want to run the executable. And in the current directory is greet.py. This is what I forgot the first time, but as Nathan pointed out, we would have crashed anyway. So we don't actually have to call the Python interpreter. We can put that right in our Python script. That will probably be useful. We can do it in Windows as well, but it's just a mess. Shebang, and then on Windows it's C:/users. Then your username, so it's going to be different. So you do have to type it uniquely for the computer it's running on. That's the biggest problem of doing that on Windows. Then app data, local programs, Python 3-11 is where it would be at on my computer. So it's kind of a pain on Windows. On Linux, it's easy because we just the Python interpreter is in the same spot on everybody's Python, on everybody's Linux machine. But on Windows, it involves the username, even if it's globally installed. So shebangs work, but they're just kind of a pain on Windows. So quite a few useful things there. Hopefully useful. Just grabbing a single branch instead of the whole repository. Orphans, so we can just grab a single commit and then pull that off from the rest of the repository. We lose all the previous history and stuff. So when repositories get huge, like to the point it takes a few minutes to download it. One thing if you ever accidentally upload a virtual environment to GitHub, right, that's going to have thousands of files that every time you try to pull from your main branch, it's going to download that. Right, you forget to put the .bemb folder in the git ignore. You end up with thousands of files there, so it takes forever to download when you try to pull or clone that repository. Cloning a single branch can be useful because then you can clone it down, orphan off a particular commit, and then get rid of that part, and then bring that back in to replace it without that. Different tricks like that. Different things like different uses for that. Forking, we saw that as sort of the original purpose of GitHub. Lots of uses for that, but a copy of the repository, but instead of our own unique copy, it's still connected so that if we do something really cool, we can notify the original owners of that repository that something really cool happened. Or combine things, like the group projects. Making up an example earlier has been in my mind for like an hour now. Like one group did Battleship and the other group did Rock, Paper, Scissors. So it'd be cool to fork off both of those into a new repository and combine the games. So it's like Battleship, but you have to choose the spot. That's been in my mind for like an hour. If you all see somebody fork off your repositories over the next 2 weeks in the break, it was probably me trying that. Autocorrect can be useful for the commands. It won't get our parameters, but we can put things in hooks and automatically run scripts as they happen. Oh, and anything we have in hooks, anything, if we put any unique hooks in there. It's 7:15, it's time I want to wrap up. Way back early in the semester, you all remember seeing the Git attributes. We can call the scripts and hooks from Git attributes. Just put your regular expression, your pattern matching, which in most cases on Git, it doesn't seem to be a lot of pattern matching. It seems to be just the file name we want to work with. But it technically is still a regular expression. So we're just looking for the regular expression for one particular file is the name of that file. And then a space, and then put the hook that you want to call. And it will look in the hooks folder first for the script. So that was about an hour and 15 minutes. That was kind of what I had in mind. Hopefully you found this semester useful. Git is incredibly useful for programmers, not just programmers. There's lots and lots and lots of reasons why we might want to do some version control. It's also very useful for music and videos, things that we're going to do multiple edits and mixes of. Presentations, presenting to the customer, if you're like web development, that's a big one. You're gonna have different style sheets. So just do a different style sheet on each branch and maybe set up like a quick TK interface GUI so that you have a couple buttons to click between those branches and then you're like one click from the other style sheet. Throwing it off to the customer, trying to see which one they like, you can jump back and forth between them really, really quickly. Incredibly useful for that. Lots of reasons we might want version control. Sometimes if you're making your software, you might just put it on the save button. That way, when your users are just save the file like normal, they automatically get versions so they can go back to it and stuff. And we work right into our code. Lots of reasons to use it, but it is one of the main operations in the software development industry. That's why it's a course that's included. Hopefully y'all enjoyed the course, learned a little bit from it. Hopefully your knowledge of Git is more now than it was back in June when we started. So I guess that wrapped it up. Keep my contact information around. I teach more than this class. I'm always happy to help. So if you have questions, feel free to reach out to me. I'm always happy to help. Otherwise, you all have a wonderful break. And I guess I'll be coming you all in the fall, or if not, y'all have a good one. I'll see you.
Thank you.